Welcome to episode 22 of the all-wheel drive Mustang project, Project Traction. Once again, all kinds of great progress in this episode. I'm going to focus on two things. One is finalizing the mounting of the front diff, or how it is supported to the engine block. And then the finalization and the completion of the cross member. And the critical part of that is mounting the rack and pinion, which was a little bit of a project, we'll say. Well, once again, there's a lot to cover, so let's get right into it. So once again, working upside down here, but I got the motor mount out of the car. I mentioned a couple 3-4 videos ago that this was originally going to be just a mock-up motor mount or engine mount, but now I'm going to send it. And I had already made some simple provisions here to be able to integrate a mount between the differential, a bracket, I should say, between the differential and the engine mount. That's what these, it's a little hard to see it, so this is for. But I'm going to be forced to cut these off, which is fine. This was all just an experiment. This wasn't even meant to be the final version. And so my next big task is to finalize the design of the diff cover. To be able to move the differential as far forward as I did, there was no hope of using the stock Toyota cover. And so, plus it had a big mount on it, I had to cut off anyways. So I'm trying to make one as basically tight fitting as possible. And then basically the limiting factors, there's still going to be a little notch here to clear the AC compressor. And then I also flipped and put the fill and the vent, remember this is all upside down, on the other side. These were over here on the stock Toyota diff. But also as part of that, I'm going to extend an ear down, or at least square off this corner, and then incorporate a feature in the engine mount that'll bolt into that. So now we have the two bolts up here, and then there'll be a large, maybe 1 or 2 bolts, I haven't decided yet, here that'll triangulate that. And then the next thing is, it's hard to see with all black here, but there's a bolt here, and then there's 2 mounts here. And I need to incorporate a bracket. Wow, it's hard to see, but a bracket from here down to something on the motor mount. Whether I cut this off and make a new one or not is the question. But that's what I'm working on right now. My first mission was to figure out a part that would tie these 3 mounting bosses into the motor mount, as previously discussed. I'm not quite sure what Toyota was thinking, but these 3 threaded holes are not in any kind of common plane or orientation. But after a whole bunch of measuring, I was able to whip up a part in Fusion 360 that would create a nice blank canvas to then mount another part, this bracket here, that would go from the differential up to the motor mount. Once the design was complete, it was just a matter of laying out some tool paths in Fusion 360, squaring up some stock, and going to town. Here you can see the beginning of the bracket that bolts to those 3 bosses on the differential. Here's the start of the second part, the part that goes from the differential up to the motor mount. And here you can see the final product and how it ties everything quite nicely together, and really should make a pretty rigid assembly supporting the differential and tying it into the motor mount. Got the painted differential mocked up in the car with the new rear diff support and the 3D printed diff cover here before I start making chips on that. And it's really hard to see. You can see how it barely clears the AC compressor, but it worked out just as planned. So now I'm quite confident in making chips. And then it's got this extra ear on it here, and I'm going to take it off and make an extension to the motor mount to tie into that, so the differential will be triangulated in 3 different directions. I also need to, I marked the bell housing here. I need to clearance the bell housing for the drive shaft so I can mock that up. And so that's kind of my next mission, is to take the diff back out, get the motor mount finalized back in for good and painted, modify the bell housing, and then actually before machining the diff cover, we're going to get the front cross member and the rack and pinion mounted. So I'm bound and determined to just make some decisions and get the rack mounted today. And so it's kind of all coming together here. The diff is mounted in its final position. It'll have to come out for other reasons and get tweaked, but I have a mock-up CV joint here, just for looks right now. But basically, I need to get the rack as far rearward as possible and try to keep it at the stock height. Even after cutting this ear off the rack, the limiting factors are two things, basically. The angle is determined by the clearance of the jack shaft, and I'll show that on the other side. And the fore and aft position is determined by where it's going to hit the diff cover, or the diff. And you know, this is a 3D printed diff cover in there still, which I've actually cut the bottom out already. So he's one more generation. But it basically is hugging the ring gear as tight as it possibly can, and that's, you know, independent of the housing and everything else. The ring gear is the ring gear. You can't move that. And so that's one of the drawbacks of moving the diff forward in the car quite a bit, which was a huge help for the CV axles, is causing me a little heartache with this. But at some point you just got to send it and not overthink it. So that's today's mission, is to get it as far back as possible, weld in the mounts, and start completing the cross member and getting it all ready to go. So on the driver's side here, the limitation is, you know, this is basically the clearance of the jack shaft. And so my buddy Harold, it's a little hard to tell right here, but this is basically a fake steel jack shaft that got pressed into, or at least slid into, the support bearing in the oil pan to kind of act as a placeholder. And then I machined this aluminum spacer here just to slide around it. Let's see if we can get in there. And that is to act as a spacer, right? That way, when I'm working on it by myself, it'll keep the rack and pinion the right distance away from this jack shaft. And right now I have a 1/4 inch of clearance, which should be more than enough. And to be honest, this has turned out to be not the critical clearance thing. This is going to work out quite well. I could be much farther. I could basically be, you know, much farther back. Still not stock, but farther back. The limiting factor is what I already showed on the other side, which is the clearance to the diff itself. And so the question is, and I don't know the answer, I just got to send it here, but what's more important, the fore and aft position of the rack or the up and down position of the rack? I probably could get it farther back if I lowered it down and then basically used like a bump steer kit on the spindle side of it to also then lower the outer tie rod to get the angle right for bump steer. I actually agonized over that decision for almost a week, trying to figure out how moving the rack was gonna affect the Ackerman steering. That's what I was worried about. And I broke out all my books. I have tons of suspension books and scoured the web. Did find a couple good articles on double pivot steering systems. There's really a pretty good one on Autotopian. But anyways, ultimately I decided it was worth moving the rack down. So I cut off those rails I showed earlier in the video and a few videos ago that it was an attempt to keep the rack at the stock height. I basically cut those off, which allowed me to move the rack down, which then allowed me to move it farther back, closer to the diff. I then did a little bit of surgery on the rack itself, got rid of some bulk you can see in the pictures, and then proceeded to, so now that I lost the rails, I had to basically try to hold the rack centered in the car and kind of float it in space. And so I got a jack, basically a jack stand and some different equipment to hold it in place, and basically tried to weld it and tack it together underneath the car with it clearanced against the diff and around the jack shaft and getting the steering lined up. That, at least on the second attempt, ended up working, and I finalized the whole rack mount and proceeded to then finish the rest of the cross member, which basically was cutting clearance for the CV axles and plating over the mount for the lateral control arms for the front suspension, and then making the two verticals that go up and tie into that structure that holds the motor mounts. That all was actually pretty straightforward, and I don't have a whole lot of footage of that. It's just cutting and welding and tacking together. And then I proceeded to fill in the opening I had created to clear the diff and paint it and start mocking everything up in preparation of putting it all back in the car. Cross member ready for paint. Here's all the final mounts for the rack and pinion and clearance for the diff, and then obviously the vertical tubes that come up to join with the body here and provide clearance for the CV axle go right through here. Turned out pretty awesome. Put some double gussets up here for some added strength, and I'm just gonna put some paint on and should be ready to go in the car. After all the welding was complete, it was time to paint it black and put it back. So after a couple coats of duplicolor chassis black, I proceeded to start to mount the rack and pinion back on and the sway bar in preparation of putting it back in the car so I could mock up the suspension and check the bump steer. I was a little concerned about the bump steer, so that was my first goal, was to get everything bolted back in and check the bump steer. It's late on a Friday night, and I just got the basic suspension back in, the all the modified cross member and the spindle and everything, and with the relocated rack I kind of just wanted to get a gut feel for how bad the bump steer is. So this is pretty kludged up for, but it's a Friday evening, so basically I put a mirror on the spindle and have a laser pointer that then has a mark or reflexor onto a piece of cardboard here. And well, I'm at approximately ride height right now. I'll jack this up and I'll show you how much the laser is moving here. There's full compression. Obviously it's exaggerated because of the distance here, but it is quite horrendous. So luckily I bought a bump steer kit and I can start messing around with it, but I just thought it was kind of humorous how bad it was, which is not too shocking. Okay, well, it's now the next day, and I've set up a little better system for trying to measure the bump steer. I got the laser mounted on the tripod, hence why the camera's not on it, and I got an actual straight mirror and have a magnetic mount going to the spindle, and made a little welded on a little piece here to a bolt with some double-sided tape, and have a piece of straight actual glass mirror so it's straight, and then got my piece of cardboard here vertical, and I've gone through just a couple iterations here of figuring out spacers to get the bump steer correct. And let's see if I can hold the camera steady. I'll show you that it's pretty good now. So if you watch the line, we zoom in here. So you can see how this is full droop. This is right here is ride height, and this is basically until I hit the bump stop, and they're all right in a line. So it's pretty awesome actually. I was concerned with the rack relocation I wouldn't be able to get the bump steer right, but it clearly is going to be just fine once I have the kit on there and get all the spacers right. So I'm going to do the other side, and now then I can assemble the struts, put the springs in, and get it ready to put on the ground. Okay, so now on the driver's side I have the bump steer kit installed with the same spacers as the other side, so it's to kind of show me how accurate I got the rack into place here, relative, you know, side to side, and how consistent are my spindles. So once again, I have it lined up on the wall here, and there's a mark right there. And let me see if I can hold this while I pump. Probably not. But anyway, so as I jack it up, you can see it's still very close to being right on the mark. Yeah, and I'm quite excited that bump steer wise, it seems like relocating the rack with the bump steer kit, you know, basically tweaking the outer tie rod position is now not a big deal. The bump steer is totally fine. It would be kind of cool to use an OEM tie rod in, but whatever, it's not that big of a deal. It's pretty common to do what I did. Now the next thing is, did it screw up the Ackerman, and if it did, how bad? That's a little trickier to measure, and to be honest, I'm not even going to try to measure it until it's back on the wheels and has an alignment and everything, and I can basically gotta have it on the ground to really do it right at ride height, and then measure the relative angles of the two wheels turning from the center to the one side. But that for sure is not as critical as bump steer from a driving it safely standpoint, and so I'm not going to worry about that until it's on the wheels. But anyways, rack's working. Well, that's a wrap on another episode of the all-wheel drive Mustang project. Once again, I kind of covered a lot in this video, and I'm curious, leave a comment below. You know, I assumed my audience would know what bump steer and Ackerman steering is, and let me know if you need more detail on that and why I'm concerned, especially about the Ackerman still. The bump steer obviously I solved. So if you have any questions about that or want more details about why I'm confident it's going to be okay because of the dual pivot front spindles, or what it even is in the first place, leave a comment. Otherwise, I appreciate everybody watching. Please give a big thumbs up, and once again, thanks for watching.